Students, I will start with a new class, and that is a new chapter, mechanical properties of fluid. Sorry for the voice, this is because of cold, a little bit sore. Now this chapter notes I have already given to you all. You can just refer them. Okay, try to arrange. I had given them. I think most of the this chapters which are there for this exam I've given. Out of this, there are two parts actually. Two of the notes are having same mechanical properties of fluid only. I'll just share the slide. If you see, you will be able to understand which notes I'm talking about. Better. This one. Just see this. These notes should be already having it. Suppose if you have, I have given it to you. If you all have lost it or something, it can just take a print of this. I'll just send us. If you all don't have, just let me know. I can send you all the PDF and then you can take a print. Now this is clear, like theory part, starting of the theory part. I will not dictate, nor you should waste your time. You can directly refer the notes. It's already in the points form. There's nothing like there's a big paragraphs, and then you have to try to find out the points from that. Not needed. Okay. Just keep these notes ready when I'm explaining this chapter. Let's start now. So since we are doing the chapter mechanical properties of fluid, we should know what is a fluid. Definitely, it's a simple definition. A fluid is any substance which can flow. Means a solid substance will not be able to flow, but a liquid, we have seen, it can flow. So there are important properties of a fluid. The important characteristics of a fluid. The first one is the atom or molecules in a fluid are arranged in random manner. This is the first point. No need to write anything. Just when you are studying, you refer directly the note. If you have a tendency of losing it, just staple it to your notebook and keep. So the first point is, so we know that fluid always flows. Now the properties, the first one they are trying to say, the atoms or molecules in a fluid are arranged in a random manner. So what happens, the difference between solids and this, they are all tightly packed for solids. But for liquid, suppose, then the atoms are a little bit more free. So that's why they can move easily compared to a solid. In solid, they are very densely or tightly packed. That's why you see, notice that the solid will not easily move until and unless maybe you put some pressure and all that. But fluid, it will easily move because the atoms or the molecules are light this. Anyway it is. But these will solids will always have a pattern. This is random manner. and they are far away or loose from each other. But they are bounded, but only thing there's a distance, like gap compared to a solid. So that is the first point. Second point of fluid, you directly refer the notes now. A fluid cannot withstand tangential or shearing stress for an indefinite period. It begins to flow when a shear stress is applied. Shear stress we had studied in one chapter under mechanical properties of solids. Shear stress means what? If you are applying this here, there's a box suppose, then the box will slightly bend from the original place. Maybe if this was the original, then the box will bend like this. So that is called as a shear or a tangential force on one of its face. Okay, they are trying to put force, then it will bend. Now suppose this was a cup of tea or some glass where there is water. Now I am putting some tangential force on it. Now the cup will bend. The glass may be full. Now I've applied some force on it. Now the glass is bent. Okay. So what is going to happen? Obviously now there's a fluid inside. The fluid cannot withstand, means cannot be able to stand a force. So what is going to happen? All the only how much ever it is bent, that much space to empty, the liquid will flow out. That is what they are trying to tell. A fluid cannot take withstand, means cannot handle stress for an indefinite period, for a long time, or for a short time also. It begins to flow when the stress is applied. Force is nothing but this is same as stress. Force per unit area is, you know that it is stress, so it will flow. Then third one, a fluid has no definite shape on its own. It is ultimately going to take the shape of the containing vessel. So you know that if you take a glass, it will take the shape of a glass. If you take a bowl, it will take a shape of the bowl. So whatever shape in this liquid you pour in, it is going to take the shape of that particular vessel, which is going to hold the liquid. Okay, so that's why the fluid has no modulus of rigidity. This rigidity also I have done already. Nothing but a stress upon this also, strain. Modulus of rigidity for liquids means how every substance would have certain modulus, how well it is going to hold itself. Okay, this is a square shape. This may be a rectangular shape. For solids I'm talking about. Now this is holding a shape by a cylindrical shape because, or a rod shape, because all the molecules are rigid. Rigid means tightly affixed to each other. These are not rigid. It will take any shape. So that's why it does not have a modulus of rigidity. And the fourth one, a fluid can exert or withstand a force in a direction perpendicular to its surface. Now suppose if you have, means what, water. Now all this water which is trying to put a force, will try to put a force in the bottom. Always. This is its surface. So it's a perpendicular force by the water towards this. Imagine if this was very weak, suppose this whatever bottom of the that container is very weak, and now you lift that container up. It may be a fine plastic type, okay, and this is suppose weak. So what first thing what is going to happen? The water will not try to flow out from this side. Whenever you lift this, and suppose this is a this old container which is about to break. So first thing what is going to happen, if you notice, this will break off and the whole water will come rushing out if you lift the box. So always whatever is the fluid inside, it will always try to exert a perpendicular force towards its surface in the direction perpendicular to the surface. If this is the surface, force is downwards like this, so it will look perpendicular. Now both liquids and gases are fluids. What's the difference between liquid and a fluid? Liquid is 100% of fluid only, but now they put gas also under fluid because anything that flows, any substance that flows is a fluid. So obviously you know that gases will flow. So gas is flowing means it is a fluid. Okay, so these are the properties of fluid. Next is thrust. This is not that thrust, I trust you type. Thrust is nothing but basically a force only. Okay, what is the then difference between force and thrust? This is a box. Any direction would be slanting also. If there's a box here. Anyway, force can be in any particular direction. But thrust, this could be the force. But thrust is always a perpendicular force. This is the speciality of a thrust. Okay, a liquid in sorry, a liquid in equilibrium has a fundamental property that it exerts a force on any surface in contact with it, and this force acts perpendicular to its surface. The total surface exerted by a liquid on any surface in contact is called as the thrust of the liquid. As I told you, if you put a liquid and there's a force which has been applied here, so now this force on this particular area is called thrust. Okay, so this liquid is supposed exerting this force on this, and it is called thrust of this liquid, means force of this liquid on the container or the surface in which it is in contact with. If this is the surface which is in contact with, it will apply like this. Whichever it is in contact with, perpendicular force will be exerted on this. So that is thrust. If you want, you can just write us know. It's there already in the note. Okay, force exerted. In shortcut, if you want to know. any surface in contact. Next is pressure. Pressure is nothing but how much of force is exerted on that particular area. This will be the area. If there's a liquid here, so you know that this liquid is going to exert the force. Can I consider this bigger area now? No. This area will not be included. Only this area. Okay, this suppose is a glass. It's on a bigger area, but what depends the area which is in contact, the liquid which is in contact with the container or whichever surface it is. So this area is to be considered the force. So pressure is force upon area. How much of force is acting on this much area? We know that units of pressure in previous chapter also we have seen it is either Newton per meter square or we write it as Pascal. Or in CGS system it is dyne per centimeter. This is SI unit. In CGS suppose you want to know dyne per centimeter. This formula we already know, pressure is force upon area. In terms of letters it is P is F upon A. This we will be using many times in the derivation. Next is the practical applications based on the concept of pressure. The first application is the first one says a sharp knife cuts better than a blunt one. Okay, so what it says. Now this only concept. First we'll write pressure is force upon area. Now first before doing the applications, try to understand this. If you're increasing this number, okay, area is increasing suppose, then what will happen? Pressure will, this you are keeping same suppose, this you are not changing. Pressure will decrease. Just look at this example. I'm making it as 10 by 2 first. How much it will be? 5. Now I want to increase the area. 10 by 3. So what is going to happen? Something 3 point there. P is 10 by 8 or 10 by 5. So what is going to happen? As you increase the area, what is going to happen? Look at, directly put the values on and see. As the area increases, pressure will decrease. So this is what you have to understand. Whenever you have an equation, anything in the denominator, suppose if you are increasing, whatever is there in the numerator will decrease. But if you are decreasing this, if area decreases, pressure increases. As you decrease the area, your pressure will increase. Okay, same thing concept is of the knife now. There's a knife, okay, there's whatever. Now the area, suppose this is a blunt one and this is the sharp edge. Okay, the diagram is very sharp fine one and this is slightly blunt one. Suppose the edge is a like the edge of the knife. So what is going to happen over here? For sharp knife, you know that area is smaller, and for blunt knife means it has become almost flat. Blunt knife means a flat knife. A flat knife will have bigger area. So what is going to happen? Smaller the area, force you are keeping the same. Suppose you are trying to keep the same on both the knives. What is going to happen here? Pressure is bigger or large. Here, less pressure. So wherever there is more pressure, it will be able to cut vegetables or whatever it is faster. Flat knife, you'll have to put more pressure then because this more force, okay, to cut the knife because area is more. Same, this formula concept. Second one, railway tracks are laid on the wooden sleepers. Okay, there's something called as wooden slippers which are put. This spread the force due to the weight of the train on the larger area and hence reduces the pressure considerably. This in turn prevents yielding of the ground under the weight of the train. Means what? There'll be some below the track, okay, there'll be some wooden, some kind of this provided support under the this. Why is it so? Is because the train is very heavy. Okay, the train is going to be very heavy. Now imagine on that small track, the area is very small of the train. The tires wheels are moving. So the weight of the train will be so high that this can go inside, no? The pressure, because of the pressure, the track can go inside. But because of that, there are wooden this provided to take away means to bear the pressure. Basically, they are used wooden thing are used to reduce the pressure from the train. And the third one, it is difficult for a man to walk on the sand while a camel walks easily on the sand. You have seen if you go by the beach side and all, when you're walking on the sand, what happens? Your legs will try to go inside the sand. Or means it, walking on the plain ground and walking in the sand is different. Why is it so? Because you know that the sand is moving around. It will try to, it tries to flow like kind of. Although it is this not fluid, but there is more tendency that the sand will move. So what is happening the moment you keep your leg, your feet is putting pressure on the sand. So that's why your leg is trying to go inside the sand. For camels, now if you notice, they have a larger area compared to your feet. Okay, So what is going to happen? More the area is more for camel. So therefore less pressure. Here what is going to happen? Here your feet area is small. We are just comparing with the camel. So if you walk in the sand and if camel is walking, whose pressure will be less? Camel's pressure, because the feet area is more. Then the fourth one, pins and nails are made to have pointed ends. Okay, the moment you keep a sharp pin, imagine this was blunt like this, and now you're trying to put it inside the wall. The nail, okay, if you try to put a hammer, it will be difficult. Why? By making it like this blunt, you know that area is more, so less pressure will be there. But if you have a sharp knife, area is small, this contact, whichever it is coming in contact with the wall, area is less, so pressure will be more and it will be able to go inside the wall faster. Okay, so these were the applications. Now we'll calculate what is the pressure in a liquid. So we'll consider liquid. This is the height, suppose, of the liquid. The whole this cylinder area is A. Density of the water is rho. Okay, so you know that a force is acting towards the bottom of the cylinder due to the weight of the liquid inside. So the theory part now is there. Okay, you can directly refer here only. That I'm only explaining the derivation part. The starting theory part, consider cylinder and all, it's there in the note. Consider cylinder of cross-sectional area with liquid filled, so whose density is rho, height is h. There is a force which is acting on the bottom of the cylinder due to the weight of the liquid inside. Therefore, the pressure exerted by the liquid on the bottom of the cylinder is given as, just now we saw the formula. What is the formula for pressure? Nothing but force upon area. The pressure is F upon A. Now we also know that force is mass mg. So what will be pressure? Mg upon A. Now we also know that density is mass upon volume. That is, rho is m upon v. So v, if you bring this side, that is m. So m you put here. Pressure is nothing but rho v. Okay, before that, again, this is volume. So volume is, it is length in or whatever cylinder into its height. Volume, you know that it is always area into the third one, the length or the height. Whatever is the surface area and multiplied by its height will give you the total area of the cylinder or whichever till where the liquid is filled up. So this will write rho, volume is nothing but area into height is m. So rho A H is m. Put the value of m over here. A and A will cancel. The pressure is rho H, where H is the height, rho is the density, and G is the gravity. Acceleration due to gravity, which is 9.8. So this is the pressure formula for a liquid in terms of density. If you want in terms of mass and all, you can use this. Next is the Pascal's law. Pascal law states that if the pressure is applied to an incompressible fluid, then it is transmitted equally through the entire fluid without diminishing. What they are trying to say is, suppose there's water here, maybe. Then there is a equal force applied on that. Now maybe another something I'll consider. Incompressible means there is another, suppose something fluid is there, okay, a container is there with some fluid inside and I want to put pressure. Sorry. So what Pascal is trying to say, whenever there is a pressure which is applied, there's an equal pressure. Okay, there's an equal pressure which is applied throughout the incompressible means cannot be compressed. Compressed means area cannot reduce or quantity. Quantity will not get reduced if you are trying to pressurize it. No matter how much you try to compress, it will not get compressed. No, suppose this only example will take. Is connected here. Let's suppose a bigger container connected. So what Pascal tries to say is there's a piston kept here. Like consider this is all filled with fluid. Okay, maybe they are at equilibrium, whatever. Now what you do is you try to put some force. This piston is tight over here. This will not, water will not come out from this side. Then you're putting pressure over here. So what is going to happen? Incompressible means this water will not get, fluid will not get compressed even if you put pressure. So what is going to happen, since it is not able to compress, it will try to go in this side. Now you are putting pressure on this, or force applied. The moment you are applying, how much ever force you are applying here, that same, with that same force, the whole thing everywhere, it will travel with that force, same force, and that same force will be applied now on this part. How much of pressure, that force you're applying here, accordingly this will move upwards now, because the whatever you're pushing this side, that needs to make that much space this side, no, in this cylinder, otherwise where will that fluid go? Otherwise the tank will burst. If this you cannot, this is not able to move up, this also you're keeping fixed, and this you are going on pushing, then this whole system will break and fluid will fall out, because it needs that space whatever you're pushing in this, automatically this will come out. So Pascal's try to say that whatever pressure you're applying, force of pressure, it will flow through the liquid throughout, or equally transmitted. So write the Pascal's law. It's there in the notes. Just copy as it is. It states that if the pressure is applied to an incompressible fluid, then it is transmitted equally throughout the entire fluid without diminishing. Means what? Diminishing means without getting reduced. Pressure, if you had applied 10 pascals, the whole 10 pascal will go till the end, wherever it can move. It can be transmitted. It's not going to become 9, 8, 7 and 0 on the way. Diminishing means it will not reduce. Pressure will remain the same. So write the Pascal's law. I will try to prove that. There's a diagram on page 2. The same diagram we have to draw. Okay, all the sides are of equal spacer. So all the strips should be of equal size. Huh? Now what I'll do, there's like a prism type. A, this is B, this is C. D, E, and F. This angle that we'll consider later. We'll just draw only this much. So consider a small element that is at A, B, C, D, E, F. This is like the first outer triangle and the inner triangle. So this is called as a right angled prism. Consider right angled prism A, B, C, D, E, F. Now that prism is kept under water. Now what Pascal is trying to say that whatever force is been applied from any direction over here on this particular prism in this incompressible list is all equal. Whether you apply pressure from here, whether you apply pressure here, anywhere on this space of this prism, everywhere it is same. This is what Pascal's law tries to say, and we need to prove it. So this is consider a right angle triangle, this prism ABCDF in fluid, which is at rest. The fluid is not moving, it is at rest. Effect of gravity is neglected. Because we are considering a very small substance. Now we'll consider the fluid is applying some pressure. Let PA be the pressure. Now see how many faces are there of the prism. There are three faces. These are the three faces. Just see. One face is this A, B, E, D, or A, D, E, B. We can read it this side. A, D, E, B. One is this face, and the second face is B, E, F, C. This is the second face, and the third one is here A, D, F, C. The three faces are this first face A, D, B, E, and B. Third one is A, D, F. These are the three faces. So let PA be the pressure. So we are applying some pressure on this face now, which I have shaded. Let PA be the pressure on ADB. Same way, let PB be the pressure on okay, and this will follow the same order as per the notes. First PA they have considered this one BFC, this space BFC. Second one is considered as ADFC, and let PC be the pressure on the third one ADEB. ADEB. So these are the three pressures which we have assumed from the liquid on this faces. Next is let thickness of prism be L. Means what? The small distance should be L. This width. This is L everywhere. This is also L. This is also L. So this whole strip's width is length, means thickness should be L. Throughout the prism, this part is L. This we don't know, the height. Okay, this is L. So therefore, AD, this also B and CF will be L. No? We'll calculate what is the force. We know that pressure is force upon area. So what is force? Pressure into area is force. We know that Fa is here. This is considered to be Fb and this is F. So first we'll calculate force on this length. Fa is Pa into its area. Pressure into area. So we know that on side BC, the pressure we have assumed it to be Pa. Area is how much? Length into breadth. So now what is the length of this space? So which space are we referring? B, E, F, C. Okay, so length I'll consider BC. What is the breadth? FC or CF. So we know that PA, BC we don't know how much it is, so we'll keep it as BC only. But CF we know it is L. So this is how we get force on the this space. Same way we'll calculate FB, that is on which space? ADFC. So again same thing, pressure into area, that will be, which is the area now? This space. So A, either you can take AC or you can take DF, but we'll take the first side only everywhere. The same way, this will also be length. Length into breadth. Breadth distance is how much? L. Then third one, FC is pressure into, again, area. AB into L. So we got all the forces, all the three forces. Now we'll consider this angle to be theta. This to be theta 1, and this angle will take is to be theta 2. Okay. BAC is theta 1 and ACB is theta 2. So we'll find what is cos theta. Cos theta is always what? Adjacent upon hypotenuse. So I'll find what is cos theta 1. Adjacent side is which one now? Which is the adjacent side? Now consider this triangle. I'll just draw it separately here so there's no confusion. A, B, C. This is theta 1. This is theta 2. What is here? FC, FB, and FA. Know that it is adjacent upon hypotenuse. So theta 1. The adjacent is FC, hypotenuse is FB. So FB just bring this side. or you can keep it that much only. Cos theta is nothing but, what is the FC? Put the values of FC. PC into AB into L upon, what is FB? Is PA. L and L will cancel. Okay. Mark this as equation 1 and keep. Or before substituting, what you do is, so I don't substitute, later we'll solve. What you do is just only write this much and keep. FB you bring this side and later we'll substitute the values. FB cos theta 1. FB will come here. So mark this as equation 1 and now you substitute the values. FB is how much? PA into AC into L cos theta 1. What is FC? PC into AB into L. L and L will cancel. This is PB, sorry, wait. This was B, just correct it. This was B. FB is PB. Okay. So AC, you keep it here this side. PB cos theta will be just that AC I brought here. Now if you see what is AB upon AC, AB upon AC is nothing but adjacent upon hypotenuse for cos theta in terms of side. So PB cos theta 1 is PC. Again cos theta 1 only. Just see what is cos theta 1. Cos theta 1 in terms of sides also it is nothing but adjacent upon hypotenuse. So it's equal to cos theta 1. So cos theta 1 will cancel. PB equals to PC. So mark this as equation 2. Now this part is over. Now we have to start dealing with next part, that is cos theta 2. We know that cos theta 2 is adjacent again upon hypotenuse. Now which adjacent side to theta 2, which is the adjacent side? So that is FA upon FB. So FB will come here. Now substitute. What is the value of FB? FB is nothing but PB AC into L cos theta 2. FA is PA BC into L. L and L will cancel. Now PB you keep here only. Now see what is BC upon AC. BC upon AC is again adjacent upon hypotenuse. For who? For theta 2 is the same thing. We will get PB upon PB equals to P. And look at now equation 2 and equation 3. If PB is equals to PA and PB is equals to PC, it's a common thing. Then you know that A equals to PB equals to P. All the pressures are equal. So that's Pascal's law. Whichever direction, whichever force you assume, they will end up to be equal. As per Pascal's law. Now we will see what are the applications of Pascal's law. The first one is the hydraulic machine. Applications, hydraulic machines. So what they do is there are two cylinders, okay? Like you see in the diagram. Now this all the entire this is a apparatus. One side has a smaller tube, one side has a bigger tube. Okay, that is filled with a liquid. It is fitted with like almost nearby frictionless because they should move smoothly. The piston should be able to move smoothly. There should not be any friction between the piston and the walls of the tube. Okay, and very lightweight pistons are there as shown in the figure. So what is going to happen is the hydraulic machine. So as you put pressure here, as I had explained, now this fluid will go this side. There's a piston here. These are movable pistons. Same way, this is also a movable only. So when once you exert a apply some force here, there'll be pressure created as per the Pascal's law. The same pressure will go up this side. So for tube 1, how much will be the pressure if I am applying force 1? Force F1 I am applying here. So pressure formula is what? Force upon area. So which letters will have to use for tube 1? Force, and this is the area. Okay, so this is pressure exerted on tube 1. Same way, pressure exerted on tube 2 will be what? P2, it will be equals to F2 upon 8. Now, as per Pascal's law, pressure on first piston, whatever pressure is created on the first piston is going to travel, and equal pressure will be created on the second. That means P1 is equals to P2. So as per that, F1 upon A1 is equals to F2 upon A2. Okay. So this equation you'll have to know later to solve problems also. And if you want to calculate what is F2, bring everything on this side. Okay. Why this side it is kept small and this side it is kept bigger? If imagine you had a big area, bigger the area, what is going to happen? Too much force you'll have to apply to push the piston down. Imagine if it was ulta. So much pressure you would have to put this to push this piston down, and this liquid will overflow from this side. Okay, because that's why what you do is you always keep lesser area from the side where you're applying the force. So whatever small force you are applying, okay, even the smaller area, but pressure will be high. So what is going to happen? A2 is greater than A1. Okay, then force also will be greater than it. Very small, less force is needed. This means less, huh? Lesser the area, lesser will be the force needed to push the piston down. So what is going to happen? The small force is enough to exert a much larger on first piston. Huh? A small force on the first piston is enough to exert a much larger force on the second. Like that small tube, small force is enough. But yeah, it will convert it into big because pressure will be less, area is big, that's why force will be large. Pressure remains the same, area and force changes. Remember that. Pascal doesn't say force is same at both the sides. Pressure is same. It changes. Okay. Force and area will change accordingly. P1, P2 will remain same. Only F1, A1 will change accordingly like this. Then second application is the hydraulic lift. Just see the diagram. Lift means this anything you want to you see for car washing and all. You take a car for washing. Suppose if you want to lift a car up, how they do is hydraulic means there's a liquid filled inside the tubes. Huh? With a last diagram, hydraulic lift. So what, this is the tube. It's there in the notes. Okay. So one side, see, always for this type, no, for whenever you apply Pascal's law, your left hand side, whichever side you're applying the force, that tube will be smaller because you need a smaller area to create bigger pressure. Lesser the area, more will be the pressure. Otherwise, you will need a lot of force to push the piston down. So that's the logic. So now, one side you keep the handle where the man will operate handle. So what is he trying to do? He will push the handle down. Okay. So when he is trying to push the handle, what is he doing? He's applying force on the left hand side. So slowly the liquid will start moving. Now it needs space. That valve, that V which is there, no, that is open first. So what is going to happen? All the fluid will start rushing towards the right hand side. Automatically, because of the pressure, Pascal's law says the whole pressure will transmit through the liquid towards the tube 2. Means although they are not separated, but I'm referring the bigger tube as the tube 2. That is going towards the right hand side. And that suppose any load, whether it may be car or any other load also you want to lift it up. So it is kept on that second piston. So that pressure which is created will push the second piston up and automatically the load will come up. Now you want to keep the load there only for some time. What is going to happen? Otherwise, the moment you leave the handle, again because of it wants to come to equilibrium, the fluid might come running back. Okay, the moment you leave the handle or leave the force, the load will come down again. But if you want to keep the load somewhere for some time, then they close that valve so that the liquid which is already gone on the right hand side will not come back. Otherwise, pull the load will put the pressure back and come back where it was before. So the explanation part is here only. The whole apparatus is filled with oil or any other fluid. Suppose when efforts are applied, means force is applied on the handle edge. Efforts means force. Huh? Force is applied on the handle edge. The pressure is exerted on a smaller piston. Okay, so now the valve will open and the oil is forced into the largest cylinder. So the largest cylinder piston is raised, means it will go up. This is how it works. And once the car is kept on the platform or the load is kept, then whichever height you want to raise, till then you keep putting pressure on the force on the handle. And last, once it reaches wherever you want, just close the valve so that you prevent the machine from running backward. And the third one, hydraulic brakes. The hydraulic brakes, the diagram I'll show you. Okay, so this is the diagram of a hydraulic brake. Now towards the right hand side, look at the page number 3. Over there, from that side I'm referring now. From the right hand side corner of the page where I've written that page number 3 is there. So that is brake pedal if you see. Now the brake pedal will be where? Near the leg of the driver. Now when the driver presses the brake, means what? Is pushing the pedal. Basically is applying force on the pedal. What is going to happen is there will be a force generator. That force will create some pressure on that liquid which it is connected to. That is named as master cylinder, that is C1. So obviously there are two wheels. Same thing works for the second one also. They have not shown. Okay, that gets continued to the outer wheels also. That fluid. Now they are shown only with respect to one wheel. From that cylinder one, the water will get pushed, and then it will come to cylinder two. How much area, based on how fast you are applying the brake or how much force you apply. So once it is there, here there are two movable pistons. Okay, so what is going to happen is the two movable pistons. Sorry, I think I have forgotten to unmute. Okay, I was explaining you the hydraulic brake. Okay, so hydraulic brakes, what is going to happen is when you push, when the pedal is this, the driver applies the brake, this pressure will be created, both these pistons can move. Now this piston will come and touch the wheels. So because there is a friction, anything you are moving and you even touch your hand to the wheel, obviously there is a friction created, and because of the friction, then the wheel will either slow down or stop running based on how much force you are applying. Then the two advantages are given of hydraulic brakes. Hydraulic means whenever you are using this particular system, putting this fluid inside. So that time there's a equal pressure created on both the wheels. So there's you can always avoid skidding of the vehicle. Otherwise, what happens only on the front, if you put extra pressure on the back wheel, there is no this brake applied, then there are chances that the bike or car will skid. And the second advantage is that even a small force is enough to create a large pressure in terms of hydraulics. I'll stop here. Next class, I'll start with surface tension and the problems which are there. I'll solve towards the end of the chapter.